A few weeks ago, this sparking pile was a discarded photo. Today, it is the first step toward a new coffee cup. It started at a dewatering facility. It's fast, it's precious, and the mission is simple. Keep clean glasses away from anything that should never enter a furnace. Because one glass is truly clean, it can be melted and remade, not as trash, as raw material. The hot end begins with the molten glass. It removes like honey, but everything is controlled like a lab. One error here can affect thousands of cups. After forming comes patience. Glass must cool the right way on a pan residue inside an annealing layer. The inspection bright light, strict stance, even a tiny scratch there can mean rejection. Now rewind and don't truck cullet glasses from dedicated bins because mixing glass with trash is equally collapsed. The load drops into a hopper and instantly the system starts sorting, filtering and removing contaminant. First, metal removal, steel caps and wires get pulled out by the magnets, while the heavier glass keeps moving. Next, non-furnace metals, they are kicked away by the precious timing and physics, because even tiny fragments can ruin a finished cup. Ear knives blast off light contaminants like plastic, film and paper. The goal is not just recycling, it is high quality recycling. Optical sorters and intelligence. Cameras detect color and unwanted pieces and air jets separate them in real time. Watch the steam split. Color separation is not cosmetic. Clear glass needs clear inputs. One major threat is sneaking. Ceramics and stone. They look harmless but they melt differently and create defects. This is why human steel matters. Gloved hands remove what machines might miss. Next comes washing. Labels, residues and dirt must go. Clean melt starts with clean feedstock. Then dewatering moisturizer is removed, so the cullet behaves predictably when it makes heat. Now the clean cullet is stored. At this point, it is not waste, it is valuable raw material. Next, crushing. The goal is not destruction. It is cold, consistent size for stable processing. Screens grade the cullet. Fines separate from the larger pieces because consistency improves melt quality. Dust extraction matters. Fine glass dust is messy, hazardous and it interferes with clean processing. Other metal parts catches what escapes earlier. Quality glassmaking is a chain of protection. Micro cullet flows like glitter, but too many fine can change melting behavior and increase dust losses. The conveyor looks calm, but it represents hours of sorting decision. Then sampling. Plants do not must hope, they trust measurement. Under black lighting, impurities goes up fast. One wrong shard can become a visible defect later. Once approved, the stream moves into batching. There are recycling meets chemistry. Glass is a recipe like silica sand, soda ash, limestone and cullet, measured and blended with industrial accuracy. Silica sand is the backbone. It builds the structure and that becomes smooth, strong and transparent. Soda ash lowers the melting point that makes the furnace more efficient. Limestone stabilizes the glasses. It helps the final cup resist water, wear and deluge. And cullet is the advantage. Recycled glass melts more easily than raw minerals. Mixing turns separate ingredients into one consistent batch. The furnace needs predictability, not surprises. Even the flow rate is controlled. Steady speed means steady melt, and steady melt means consistent stuff. The batch climbs towards the furnace like grain into a mill, but headed from extreme temperatures. As it drops into the hot zone, everything changes. Solids enter an environment built to erase edges and create uniform liquid. Glass melting often runs around 1500 to 1600 degrees Celsius, depending on the furnace and the product, and that heat stays on continuously. Inside the melt, bubbles rise and blast. This is not just looks, it is strength and integrity. Refining zone helps the glass go uniform. Trapped gases are pushed out and composition even out. Conditioning channels turn temperature and viscosity. The glass must be soft enough to shape but stable enough to control. Control flow and steering reduce tricks. The kind of subtle flaws cameras can detect instantly. Burners and air force hold the balance. Melting is not just heat, it is energy, chemistry, and timing. Now the cut. Shared segments the molten stream into groups, each one precisely sized for 1 cup. The groups fall in rhythm. The forming machine depends on timing, like a metronome. One group slides down the chute, still glowing. It carries enough heat to be shaped in seconds. In the hot and half, multiple lines run at once. It is mass production, but it never careless. Heat shields and protected viewing points still view everything. This makes steam temperature feels routine. Sampling confirms the melt is right. Composition and behavior are checked because a good cup starts as a good melt. The flow stabilizes, and now comes the dramatic part, turning liquid into form. Follow this scope in moment. It stops being molten glass and becomes a recognizable object. The mold opens, the globe lands, the mold closes, shape is locked in. Fast and easy. A planer presses the glass into geometry. This is how the ball forms with tight dimension control. The rim gets special attention because the clip is the people feel quality first. Cooling jet protection the mold and control the surface. That stability keeps production consistent. The mold opens again, a glowing cup appears beautiful but still fragile from thermal stress. The cups transfer toward the lehr. Their glow fades as the job shifts from shaping to standing. Mortal lines and tiny mismatches are watched closely. Small errors become big visual flaws under inspection light. Multiple cavities run into synchronized cycle, a chronography of clamps, presses, and transfers. As cups leave the hottest zone, they turn clear, but they are not safe yet. Stress still live inside. Stress pattern can be detected because invisible tension can turn into a sudden crack later. The annealing layer is controlled cooling, a long tunnel designed to relieve internal stress without shocking the glass. Temperature zone steps down carefully. The goal is simple: let the glass relax. This is engineered patience. The cup moves steadily while heat and airflow do quite work. You cannot see. Reflection settle. This is the difference between a cup that lasts and a cup that fails on the first hotline. When cup exists, they look finished, but the plants treat them like a promise that must be proven. Even sound tells a story. A clean ring suggests good stress relief. A dull tone can hit problems. Now we enter the cold end. The mood changes, less fire, more lights, and stricter decisions. Some lines and tempering. The glass is reheated, then cooled rapidly to increase strength. Tempering heats the glass to high temperature, then uses a fast air quench that creates a strong compression layer on the outside. Post-temper checks confirm the process works because tempering without control is just a stress in dispute. Vision system inspects shape, surface and clarity at high speed. Defects are rejected instantly. A flow curve is diverted, not squeezed, because rejection glass can return to the cullet loop. Humans still have a role here. Fingers spin rims, eyes catch subtle scratch, and borderline defects get real judgment. Sorting lines separate a grade curve from rework streams. The loop stays efficient and the quality stays trustworthy. Finally, packaging, dividers, cartoons, warp, pallets, and the quiet ending.
If this breakdown helped, hit like, subscribe, and share it with a friend. Watch the next one on screen.